Good day, guys. Alright, so today what I want to do is I want to discuss another projectile motion problem. Okay, so let's get into it. Let's look at the question. Alright, so the question goes: a football is kicked at an angle of 37 degrees with a velocity of 20 meters per second. So, and then it proceeds with 5 questions that you'll have to answer. Now, whenever you're given an angle and a velocity, well, the first thing you can do is break that velocity, initial velocity, down into its x and y component. That is going to be proven useful, right? So I'm just going to calculate it, quickly right over here. All right. So as you can see, there's a pop-up here that tells you exactly that. Okay, so let's proceed to the first part of the question, which is to calculate the maximum height. Now, the maximum height, what it's referring to, is the biggest value or is the largest value of y, right? So whenever there's a large value, the biggest value, and there's a peak, right, we know that it's going to be dsy over dt, right? It's going to be 0, and this is just the velocity in y. Okay, so we can refer back to our velocity equation for y, which is vy equals to uy minus gt, right? Because this is g is just ay. The assumption here is that ay is just negative g. Okay, so once we have that, we can rearrange and substitute. So we can substitute in there. We have uy here, which is 12.03. So 12.0363 minus 9.81 t. We can rearrange that for t, right, which gives us 12.0363 over 9.81, and that should give us a value of about 1.227 seconds. Okay, so once we've done that, we know that at t equals to 1.227, the maximum height is achieved. So all we need to do is calculate sy when t equals to 1.227, right? And this can be found if we substitute the t into this particular equation, which is uy t plus half ay t square. Okay, so here we can substitute the relevant values, which gives us sy, which is equal to h, equals to, so uy is 12.0363 multiplied with 1.227 plus half negative 9.81, okay, multiply with 1.227 squared, and the answer or the value of h that you will get or you will obtain is approximately 7.384 meters. Okay, so obviously the answer is going to be different depending on how many decimal points that you take when you're calculating t. However, it's going to be around 7 point something, 7.38, 7.5, probably around there. Okay, now the next part, which is the time travel before the football hits the ground. So what we mean by that is, let's draw it out. Okay, the football is kicked and it's going to take a parabolic shape, and then when it hits the ground, it's going to return to the same height when it started. So sy, right, going to return to the same height that it started. So that means at the beginning it starts at 0, and when it ends it starts at 0 as well. So that means if we just solve for sy equals to 0, right, we can get two values of time, and we know this to be true because it is simply uy t minus half gt squared. See, this is a quadratic equation, right? When you have a quadratic equation, it is basically a polynomial function with the highest order of 2. If it has a highest order of 2, that means there are two solutions for this. Okay, so we can rearrange that, right? You can take out the t to get this equation. So uy minus half gt equals to 0. So the first solution being t equals to 0. And the second solution will be uy minus g over 2t equal to 0. So we can rearrange that for t and obtain, let's see what we get. We get, okay, g, so uy times 2 over g, okay, which is equals to 2. So uy here, as we can refer back to, is 12.0363 over 9.81. This would give us a value of 2.454 seconds. So it takes the football 2.454 seconds to get back to sy equals to 0. Okay, so that is our solution. Now let's look at the next question. The next part of the question is how far away it hits the ground. So what that means is that, let's assume again this is sy and then this is sx. We have the ball being kicked, taking a parabolic shape, right? We want to know how far, right, between the starting point to the point where it lands. Okay. In the previous part of the question, we have calculated how long it takes, right? How long it takes. We know the amount of time, right? So if we want to calculate sx, right, at a certain point in time, we will use this equation ux times t, right? The t being the time that has elapsed, the time that has passed through or passed by. And since the time that we calculated in the previous example is the time before the ball hits the ground, right? This time is also the time that we have calculated from the second question. So if we can just substitute it in, so if we refer back to the previous question, 2.454, this is going to take the value of 2.454. And ux, again, you can refer back to here, is 15.9727 multiplied with 2.454 seconds. And that would give us a value of approximately 39.1970 meters. Okay? Okay, so this is really just asking about the range. Okay, the range. Okay. Now let's get to the next part of the question, the velocity vector at maximum height. All right, so the value of the velocity vector, right, will depend on the square root of the vx square plus the vy square. Okay, so the square root of both these components squared. But at maximum height, we also know that Vy is also going to be 0, right? Because there's the gradient is 0, okay, for the Sy. Then we can substitute in to get the square root of Vx squared, which is just Vx, right? So at the maximum height, our velocity vector is going to have the same value as our Vx, which is equals to ux. Which is going to be equal to ux, right? And this is going to take the value of 15.9727 meters per second, whereas our Vy is going to be 0 meters per second. That's your solution. Now, the last part is going to be the acceleration vector at maximum height. Okay, at maximum height, and it's not just at maximum height, in all our cases, our ax has always been 0 meters per second per second. On the other hand, ay is affected, or is mainly affected by our gravitational acceleration, which is negative g, right? And this value is just 9.81 meters per second per second. All right, so that is the end of this video. I'll see you in the next video. Thank you very much.